Good morning, grade 4s, and welcome to the coronavirus edition of our maths class. Today we're going to be talking about comparing fractions, and if you want to take notes, just please feel free. You can copy down what I'm writing over here, and you can pause the video whenever you need to kind of just catch up. So we'll start with the title of comparing fractions. And before we start with actually comparing fractions, it's probably quite important to just do some revision on equivalent fractions. Okay, so an equivalent fraction is when you have two fractions that are actually equal, funnily enough. And we can have an example here. Let's add a little rectangle here, and we can duplicate that. So we're going to make two fractions here that are equivalent. So this is going to equal that. Now let's cut this first box into thirds. And we'll color that in. That is 1/3, right? That is 1/3 because we cut our box into 3 pieces and we took one of those pieces. Now, if I cut this other box into 6, so I'm making 6 equal pieces, what do you think the equivalent fraction here would be? Well, we're going to start off by highlighting the same amount. So we can see that is also, it's the same as what we had in the previous one. All right, this is the same as what we've got over here. But now we've got 6 instead of thirds. And so this is actually going to equal 2, 1, 2 out of my total of 6. So this shows us that 1/3 is equal to 2/6. It's the same amount of the whole. It's just explained in smaller parts, right? So that's going to be our little bit of revision on equivalent fractions, and we can move on to now the main part of today's lesson, which is going to be comparing fractions. And what we're going to look at here is, firstly, we're going to compare fractions with the same denominator. So let's write that down. Comparing fractions with the same denominator. Wonderful. Now, just as a refresher, in case you'd forgotten, the numerator and denominator of a fraction, top part of the fraction is the numerator, and the bottom part is the denominator. And we actually know that this tells us what? Well, it tells us the amount of pieces that we have, and the denominator tells us what? Well, it tells us the amount of pieces that the whole was broken into. Alright, and so this is actually very important information moving forward, because we are going to talk about how we're going to compare two numbers with, firstly, by looking at the same denominator. If I looked at the fraction 1/3 and I compared that to the fraction 2/3, which of these do we think is going to be bigger? Well, we could start off by showing this with a picture, right? That's one circle, and that's another circle. And we say, well, this is going up against that, and we can then draw a line. So we're going to split these both up into thirds, as you can see there, because both of them we've got two fractions that are broken up into three pieces. The denominator tells us that the whole amount has been broken up into three pieces. Okay, so we're going to split these both three ways. And now I'm not doing a very good job here, but it doesn't have to be perfect, as long as we can see that it is broken up into three equally sized pieces. So the first one is going to be my third. So I'm going to take how many pieces? One piece out of the three. So we're going to color that in. And the second fraction is 2/3. So we're going to color two of these three pieces in. Now, just by looking at that, we can see that which one of these fractions is bigger, 1/3 or 2/3? Well, it's quite clear that 2/3 is the bigger amount. And that leads us to a rule when we are dealing with comparing fractions with the same denominator, is that if they're broken up into the same size pieces, obviously the one with more pieces of the same size will be bigger. So 2/3 is going to be the bigger fraction. This is 1/3, this is 2/3. We know that this one is going to be bigger. All right, and next up, we are going to be talking about comparing fractions with the same numerator. And now this one is a little bit more tricky, I find, but we'll go through it and we'll have a look. So let's just start by writing our little subtitle here. Now, as we discussed earlier, the numerator tells us how many pieces we have. So this is going to be saying, well, if we've got the same amount of pieces, but the pieces are different sizes, which of these things is bigger? And we're going to start off with an example of 5/6 versus, let's say, 5/12. Now, it's a common mistake to make, to say, well, 12ths are bigger, 12 is bigger than 6, so 5/12 is definitely going to be bigger than 5/6. But let's have a look and see why this is incorrect. And let's bring up a little circle again, and we can duplicate that. All right, if we compare these two, we've got one that is split up into 6 equally sized pieces, and another one that is split into 12 equally sized pieces. Alright, so to cut this into 6 pieces, let's start off with thirds, and then we cut each of those thirds in half. Alright, so we've got 6 pieces here, and if that's what it looks like, then we're going to give this guy 6 pieces also, 6 hopefully equally sized pieces, and then we can cut that in half as well, so that we have 12 equally sized pieces. We can have a little count: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. And then the next thing we're going to do is we're going to highlight these areas here. So 5 out of 6, that's 1, 2, 3 on this side. Very nice. And 3, 4, 5. Okay, so that's 5/6. And over here, let's color in 6 of these. Oh, 5 of these, so that we can show 5/12. 1, 2, 3, 4, 5. Okay. So now we've got our 2 fractions here, and can you see which one is bigger? This is 5/6, and this is 5/12. Well, which one was cut into smaller pieces? Well, obviously the 12ths are smaller because it's been cut up into many more of them. It's been divided into 12 equally sized pieces. The 5/6 has been divided into 6 equally sized pieces. If we take 5/6, that's almost the whole amount. We're just 1/6 away. But if we take 5/12, you can see that it doesn't even make it to halfway. Half would be this half over here, and you can see that it's still missing a 12th before it gets to become even half. So which one of these fractions is bigger? Well, I know that just by looking at this now, that 5/6 is going to be bigger than 5/12. All right, and I could explain that with words, saying that 5/6 is bigger because it has the same amount of parts, but each of those parts is bigger. And let's go back quickly to this other one that we did earlier. We can look at these two and we could say, well, we've got 1/3 versus 2/3. Which one of these is bigger? All right, which one of these is bigger? Well, we can explain that with words. We could say 2/3 is bigger because the parts are the same size, but 2/3 has more of those parts. Right, and it's actually quite important that you are able to explain things like that. Okay, now if we get stuck in a situation where we don't have fractions with the same numerator or denominator, we get something that we like to call unlike fractions. And so I need you to be able to compare unlike fractions also. So let's start off with a new subtitle: comparing unlike fractions. Okay, and if we're going to be comparing unlike fractions, we need to start off with an example. Let's talk about 3/4 and 1/2. Now, these unlike fractions, a little bit more difficult because, well, I don't have the same denominators and I don't have the same numerators, so I can't just eyeball it and make a decision based on that. There's no specific rule, but we could start off by saying, okay, well, let's draw a rectangle, and which of these do you think we could do first? Well, let's start off with a half. That makes sense. Okay, a half. I'll choose a new color here. Something a bit darker maybe. Oh, a little green. So let's start off with a half, and we'll cut this right down the middle here, and that would be 1/2. And we can compare that to 3/4. We could draw another picture. And we need to make sure that the holes are the same size. Otherwise, we can't compare the fractions, because if we're talking about two different holes, then the fractions don't really work out. So, well, if I want to split this into quarters, well, we split this one also straight down the middle, and then each of these sides is going to get broken in half also, because a half of a half is a quarter. Now I've got 4/4. How many of those do I want? I want 3 of those. So I'm going to color in 3 of these quarters. 1, 2, 3, and that's it. That's 3/4 of our whole. Which of these is bigger? Well, we can see that 3/4 is going to be bigger because it's a whole quarter more than a half. All right, so 3/4 is greater than 1/2. All right, we could do this a different way. We could say, okay, well, I've got 3/4 and 1/2. 1/2. And what we actually want to do is we want to change one of these numbers so that it either has the same numerator or same denominator. And we can't change it in any way we like. We need it to be an equivalent fraction. So just by looking at this, I want to find an equivalent fraction of 1/2 that will have either a numerator or a denominator of 4. And I can see that 2 is going to go into 4. So I'm going to start off by finding an equivalent fraction for a half with a denominator of 4. How do I do that? Well, I multiply this by 2/2. We always multiply it by a number over itself, because that's the same as multiplying by 1, which is going to give you an answer that is equal to the fraction that you started off with. All right, so I want to compare 3/4 and, well, this is going to be 2/4. All right, so 3/4 versus 2/4. 2/4 is a half. That's an equivalent fraction. Okay, so I'm still comparing 3/4 to a half. I'm just comparing it to a different way of expressing that half. So now 3/4 versus a half, which one of these is bigger? Well, they've got the same denominator. I compare the size of the numerators. All right, 3 is definitely bigger than 2, so I know that 3/4 is greater than 2/4. All right, so that's a good start. Let's move on to a different example. Let's look at 3/6. oh no, let's look at 3/4 versus 6/9. Which one of these is going to be bigger? Well, if I look at the denominators, is there anything I can do to change 4 to 9? I want an equivalent fraction with the same denominators. Is that going to be easy to get? No, well, I can't multiply 4 by anything to get to 9, so getting the same denominators is going to be tough for this. But if I look at the numerators, all right, let's have a look at these. This 3 and this is 6. Could I do anything? Could I find an equivalent fraction of 3/4 that's going to give me the same numerator? Well, let's have a look and see if we can do it. So the first thing we do is we're going to say, well, how do I get 3 to become 6? Well, I need to multiply that by 2. Can I multiply this just by 2? No, we cannot just multiply by 2. We need to multiply by 2 over 2 because that's the same as multiplying by 1, which means that we will get an equivalent fraction. It's equal to itself. All right, so this is going to give me 6/8. 3/4 is equal to 6/8. They are equivalent fractions. Okay, so now I've got two fractions, 6/8 and 6/9. Which one of these fractions is broken up into smaller parts, 8s or 9s? All right, I know that 9s are smaller because they are broken up into more pieces. It's a small difference between 8s and 9s, but it's noticeable. And so if 8s are bigger than 9s and I have 6 parts of both, that means that 6/8 is going to be greater than 6/9. And we can again show this with our blocks. Okay, and maybe it's good to use these this rectangle now. And we can duplicate him and bring him down here. So the first fraction that we had was 3/4. So let's split this guy up into quarters. And we're going to color in 3 of those quarters. 1, 2, 3. And over here we're going to have 6/9. So I need to split this up into 9 pieces. How am I going to do that? Well, let's start off by putting them into thirds. That's not a good third. That's a third. That's a third. And then each of those thirds gets split into 3 equally sized pieces. That's going to give us 9 equally sized pieces. Alright, so here we've got 9 equally sized pieces. And yeah, we've got 3/4, we've got 6/9, and we need to color in 6 of these. 1, 2, 3, 4, 5, 6. And let's use a different color here. Oh, is this gonna work? If we highlight this line here and we highlight this line here, it becomes not very easy to see, but if we zoom in a bit, can you see there that there's a small difference here of 1/9 between 3/4 and 6/9. All right, we said, okay, well, I need an equivalent fraction of this. I'd cut each of these quarters in half, which gave me eighths. I now have 8 separate pieces, and I have 1, 2, 3, 4, 5, 6 of those 8 pieces. So this is our equivalent fraction 6/8. This is our fraction 6/9. Which one of these fractions is bigger? Well, as we said before, 6/8 is greater than 6/9. All right, and so this is how we compare unlike fractions. All right, and the rule here is that you want to make sure that you find an equivalent fraction for one of the fractions that makes it so that both fractions either have the same numerator or the same denominator. All right, and that's why it's a little bit more tricky. It's because you have to find an equivalent fraction so that that it makes it so that you have numerator or denominator which is the same. All right, guys, if you have any questions or queries about this, feel free to email me and I'll jump on it. I hope that this was informative enough for you. Please go on to the Google form that I've set up and just fill that out to the best of your abilities. I will have a quick look through all of them and see if there's any areas that you need help with, or some extra instruction that I might need to give. Please pay careful attention when you're comparing these unlike fractions. You need to make sure that you find an equivalent fraction, and that equivalent fraction needs to make it so that you have two fractions with the same numerator or the same denominator. All right, so then we can actually compare them. Okay, thank you very much, guys, for listening, and thank you for putting all this effort in. Have a good day. Bye.